So welcome everyone. You all have already attended the last session which happened last Saturday. It was on IBDP External Assessment. So this session will focus on internal assessment, and you're already familiar with Mr. Hendra. So those who are attending this session new today, so just a brief introduction about Mr. Hendra. So Mr. Hendra comes with over 10 years of experience in mathematics, and he has served as head of department, workshop facilitator, IAEE and TOK reviewer, and as an examiner for both Cambridge and Pearson as well. And his expertise extends across multiple curricula, including IB, Cambridge, Pearson, and NZQA, showcasing his versatility and breadth of knowledge. So what we'll do, we'll not waste much time. We'll just welcome Mr. Hendra to the session, and we can start workshop. So yeah, Mr. Hendra, you can start your workshop. And I've just shared the link with everyone in the chat. So those who have joined just now, please try to access this link that is shared in the chat. Access all the slides and you can interact. Yeah, it will come as blocked. So kindly be patient with us. We'll unblock you one by one. It will take some time. Yeah. Thank you. You can start your workshop.
Thank you, Saheli. Hi again, everyone. It's nice to meet you again. Yeah, as Saheli mentioned, that today's session will be about the internal assessment, that we will focus on the internal assessment. Please let me know if you can see my slides. Yeah?
Yeah, we can see.
We can see your slides. Yeah.
Okay, thank you. So, as we know that in Mathematics Group 5 Mathematics, we have two assessments. I mean, like in every group of IBDP, that we have two assessments, which are external and internal assessment. Last week, we've done the external assessment. We broke down the internal assessment. The external assessment. Today, we will discuss about the internal assessment. So the objectives for today will be introduction to internal assessment, which might everyone already familiar with. And then selecting strong aim. How do we suggest our students to get a strong aim? And then mastering the assessment criteria. I think this is the most important part as an educator. That how do we know which criteria that when explaining to our students. And then if we still have time, we might do the sample IA marking as we did last week, and then wrap up at the end. All right. So internal assessment itself is part of the assessment that IB conducted. The weighting is 20% out of all of the assessment, which is the external assessment is 80% and the internal assessment is 20%. And the internal assessment itself, in mathematics, we call it mathematics exploration. And most likely we call that as mathematics exploration. Why do we call that? Because we want the students explore the concept in different areas, either within the mathematics or outside the mathematics. It should be between 12 to 20 pages, no more than 20 pages. It's no words limitation in this case, but there are certain limitation for pages, which is between 12 and 20. Ideally, according to the subject guide, you should either introduce or teach or discuss about the IAs between 10 to 15 hours during the class time. And it is based on student short report. It's kind of a mini thesis that the student make. Again, if you have any questions, just pop up or hands up. Yeah, the different kind of the mathematical exploration that we have, whether it's modeling. The modeling, it's most likely based on case study. Let's say if student have one of my students did the modeling of the general one is modeling of an object. One of my students did a modeling of a chess piece and find the surface area of that. So this student's model create a function on how does the chess piece looks like in a function base. And then the other style of the exploration is a new mathematics to the students, obviously, because at this point, the syllabus cover is limited, not as much as if you are taking the major in mathematics in the college. So one of the example that my student did was these students proved the trigonometric differentiation, the first derivative of trigonometric using first principle, including the inverse trigonometric. Eventually, this student take the AAHL mathematics. So those are two. And the other kind of exploration is investigating a well-known problem. In this case, the example is if you're familiar with the goat horse problem, which a participant given three doors and etc. And the most common one is the statistic, because eventually it's the easiest topic that you can explore and you can relate to the real situation or the practical application. However, me personally, in some cases, the statistic base is most likely recommended to the math AI students, since if you're taking math AI, if your students are taking math AI, the statistics are covered a lot in the syllabus compared to the math AA. Meanwhile, the math AA can take like the modeling, the new math, or investigating the well-known problem. But it's not stated specifically in the subject guide that you can split it that way. But however, like in the sake of math AI, since the statistics that cover in the syllabus is heavier than the math AA, then me personally is suggesting that the statistics is more toward to the math AI. So the second aim for today is how do we suggest our students to choose a strong aim? Excuse me. In this case, I usually start with what the students interest in. So this should come from the student themselves, rather than we suggest on doing something and the students are not interested in. It will decrease their motivation to do the work. So that's why the first thing that I always suggest is, what are the students' interests in any topic of mathematics? If the students already give their interests of anything, then we can suggest what kind of mathematics will be used in that case. Of course, it should be linked to according to the syllabus cover. And then yeah, it's related to their interest into mathematics, into the any topics. If they already give you their interest in certain topics, then we can suggest the mathematics that on the right level of the course that they choose, either SL or HL. And then we need to suggest that to the students that they explore the topic that feasible. It's not something that impossible to explore, such as if they are taking modeling and needs to gather some data, then the data needs to be feasible, need to be easy to collect, not something that needs some restriction to be collected. And then this is most important one, especially if the students are taking statistics. We suggest to avoid them to take the topics that have been done few times. Like so it will, because in a examiner point of view, if we as examiner have seen that topics, then it kind of some annoying that we mark that IAs from the students. And there are some once your students get the idea about their topics, you might ask some questions about, is the topic that the students choose is genuinely that the students interested in, not something that's suggested by the students or the parents or someone else. It should be purely from the students' interest. Or you can ask the students that, if you choose this topic, will it allow you to demonstrate your own mathematical ability? So the name of the internal assessment in group group 5 is mathematical explorations. So in this case, the students should be able to explore their understanding in mathematics or apply the concept that they have learned in different subjects or in different areas of mathematics. Or you can ask other kind of question that to make sure that this topic or this interest, this topic that the student choose is the best fit for the students itself, such as the level of difficulty of the mathematics or the topics that they interest in. In this case, I classify the main topics areas of the math explorations: the modeling, the pure math, the geometry, statistics, and probability calculus, or linking with other subjects. Again, if you have any questions, just pop up. Now let's go to the criteria, each criterion that we have. In mathematics, we have 5 criterions, which is A to E. The criterion A, presentations, it's worth 4 out of 20. Criterion B, mathematical communication, also 4 out of 20. Criterion C, personal engagement, which is related to the student's interest, which is 3 out of 20. Criterion D, reflection, 3 out of 20. And the last one, the biggest one, use of math, it's 6 out of 20. The only difference between SL and HL in terms of the criterion is in criterion E. So in HL, it's more sophisticated. It's more a challenging math to be used. Let's break down each of the criteria. Let's start from criterion A, which is presentation. In this case, according to the subject guide, there should be 3 things included in the exploration. Is the coherent, organized, and concise. The coherence broke down into: is the exploration easy to follow? The steps are clearly explained. It's not jumping around like one to the other should be follow up to the other. Its sections should be linked together. It starts from introduction and then stating the aim, for example, methodology, and then the exploration, at the end conclusion and evaluation. And this is most important. It's not too hard or too easy. It should be understandable by the non-subject expert. In this case, the students take the math, but it should be also understood by non-math expert. Concise, no repetitive calculation. For example, if the same calculation, the same kind of calculation is presented in one IA, then the students can state the calculation once and then only present the result for the rest of the calculation. It only applies for the repetitive calculation. The content is relevant to the exploration, of course. The aim and the exploration or the discussion itself should be linked. The extension is not recommended. It's not recommended to be explored in the exploration. The students should finish when the aim is achieved. The aim is stated at the beginning of the exploration, and throughout the exploration, students should only answer the aim that's stated at the beginning of the exploration. If the students want to suggest an extensions or further investigation, then the students can only suggest what can be done further for this exploration, not exploring it or writing it again after the aim is achieved. And again, it's between 12 to 20 pages for the exploration itself. And then the third one is organized. In this case, it should be included introduction. The aim is clearly stated. The rationale of what and why this exploration, or what and why the students choose this topic or choose this mathematics in this exploration. The conclusion should be presented. The conclusion should include the conclusion and evaluation should be included. The conclusion and evaluation should include discussion of the strength and weakness of the exploration, and also the further idea of the improvement, and as well as the limitation of the exploration, as well as further idea for the investigation. And the conclusion should summarize what has the students discussed in their exploration. Of course, the work should be cited. It must be cited, either using footnotes or in-text citation method. The bibliography obviously has to be included at the end of the exploration. If necessary, students can include the appendix, but it's not compulsory. It's only necessary. And then graph and labels. The graph and tables are organized and presented in the relevant place. The students need to present the graph or tables or figures, as well as its explanation or its description, and it should be directly linked to the exploration or to that section. It's not something that just adding some pictures or some tables that not completely not related to the exploration itself. That's criterion A. If you have any questions, please say so. And specifically for the aim, the students should outlining the purpose of the exploration, specifically stating what is this exploration about. Again, from the examiner point of view, especially I am reviewing the IAs from some students. If I do the review, I always start with the aim. What is the aim? What is the aim, the stated aim in the at the beginning of the exploration? Because from that I can get the idea what is the students trying to achieve when and how the students will do that. So it's the clear aim is essential to the students to in the mathematical exploration. And then if there are no questions about criterion A, let's move to criterion B, which is the mathematical communication. This is more into how the students present their ideas into paper, into mathematically using a correct terms of mathematics. There are also three things that needs to be considered: consistent, appropriate, and relevant. The mathematical presentation does not change throughout the exploration. For example, at the beginning, let's say the students define the R is the radius of a circle. The students will always use the R, lowercase r in this case, lowercase r, as the radius throughout the exploration. From the beginning until the end of the exploration, the R means the radius of the circle. So it's not changing. No ambiguity in stating the variable. For example, at the beginning, the student states the R is the radius, and then later the students state the R is the say the length of the side of a triangle or etc. It's not. It's not. The student cannot do that. If at the beginning the student state the R is the radius, then it should be used throughout the exploration. And also consistent. Let's say again with the R, it's if the student at the beginning, if the student state the lowercase r as the radius, then it consistently use that the lowercase r as the radius throughout the exploration. And then appropriate, it means good use of equation editor if the students use any equations. In this case, the students is recommended to use, if they are using Microsoft Word or Google Docs. The Microsoft Word or Google Docs, they have what's it called, their own kind of equation editor, and the students is advised to use that, since it will be used consistently. It will show, because at some point, let's say if the students use the normal letter as to define a variable and compared to use the equation editor, if you notice that there might be some differences between the normal letter and the equation editor itself. Okay, so the next one, the tables, the graph, the diagrams, the figures should be labeled. And the label is recommended at the underneath of that tables or graph or figures. It's the label should include the number and the title of that, let's say the table, that table, let's say at certain point the students present the data of population of Indonesia, for example. Then the label of the tables, let's say table 1, and then the data of population of Indonesia from certain years, let's say 2020 until 2024. That's an example. It should be consistently for every tables, graph, diagrams, any figures that the student attached to the exploration. Yeah, and if they present coordinates, then it should be title and the axis are labeled. Let's say, and the x-axis about the population, and the x-axis is the year, and the y-axis is the population. So it should be labeled clear. All variables has to be defined and explained. It's yeah, as I mentioned before, if the students use R as the radius, then it should be defined. R is the radius when that variable first introduced. So it's not recommended that the student use the formula or the variable first and then explain it. Define it after they use that certain formula. But the students needs to define certain variables or formula before they are using it. So each term of that it's mathematical terms that the student use has to be defined before they use it. And then rounding to appropriate degree. In this case, the students can use the 3 significant rounding if necessary again throughout the exploration. However, the rounding should only for the result of the calculation. The student is not recommended to round the number in the middle of the calculation. The rounding should only done at the end of the calculation, right? And in the rounding, it doesn't have to be 3 significant figures. It depends on the number that students get. It could be like certain decimal places or certain significant figures. Demonstrating an understanding of the level of accuracy that the students are using. In this case, for example, in the example of modeling, let's say the students obtain a quadratic model or polynomial model or exponential model. The students can test the accuracy of that model using what is it called? The R squared, the R squared test. In that case, the accuracy of the model is tested by the students. And then the last one is relevant. The mathematical presentation that is required to communicate the topics and aims. The mathematical representation should be linked to what the students are doing. There's no way if, let's say, if the students are talking about the circles, then they talk and then they use the term of vector, for example. It might be linked, but it's not quite significant. But unless that's a relation between that. But what I mean is, if the students are talking about the circles, then they can mention about the radius, the diameter of the tangent, or etc. Right? Do you have any questions regarding criterion B? Again, if you have any questions, just pop up. And when the students have write their exploration, you might check the correct mathematical language that the student use. For example, I often seen in my review that the students to represent the the standard form or scientific notation, the students use the calculator presentations, the one with E. Meanwhile, that is not appropriate. It's not recommended to be used in this exploration. The students should use correct mathematical language throughout the exploration. It's also not recommended to use the symbol of GDC or computer symbol, or because they often use Excel or Google Sheet. It's not recommended to use their symbols in this case. That's about criterion B. Let's move on to criterion C, which is the personal engagement. This is quite tricky. The personal engagements, again, because it's how the exploration started, they should understand what they want, and they should understand what they want to do and how do they do it and how they will get it done. So in this case, I broke it down into 5 different things. The first one is thinking independently. The students should be looking at the problem from a unique perspective. In this case, from the student's perspective, the problem shouldn't be similar to the textbooks or just explaining what is in the textbooks. It's not recommended. The students is advised to explore a certain topic to their interests, apply a certain topic to whatever they are interested in. So that's how the exploration, the personal engagements should work. And it's related to the showing their personal interest. It should provide what they interest in. The students should start with what topic or what things that they are interested in. They should explain why the students are interested in this topic or in this exploration, and maintain their personal voice throughout when commenting or explaining or reflecting on a certain result. And then exploring the topic. In this case, this is an exploration and not a summary of someone else's work. Then the students should try to explain from their own perspective and using different mathematical methods. The student, for example, there are many kinds of modeling populations of the IA examples of modeling population. The students can model a population on their own country or their own country interest, but using the data that they use should be different from what has been done. The next one, trying to learn some new mathematics or trying to apply mathematics that the students already know to new context. For example, as we know, as you probably know that mathematics exploration is the hardest to get the idea, but it should be the easiest to be done, since there is no certain things that you need to do. It's the group 5 exploration, they give you like a wide range. You can choose anything. In this case, you can relate to any subjects or any topics as long as it's your interest. It's different than the like business or sciences. They have a certain requirement to choose the topic. So that's why the students can learn some new mathematics based on the concept that they already know, or apply the concept that they know to, let's say, from to business perspective or to biology or to chemistry or any other subject. Anyway, it reminds me of one of my students. They choose the to link the mathematics to the chemistry, that modeling to how long a certain medicine can be soluted in our body. So they test a certain medicine using a certain solution, and then how long it takes to be soluted in that solution. The next one, if the students are doing investigation, which requires data, then try the students is recommended to collect the data by themselves. And then this is show that how the students engage to the topic that they choose. Again, my students who took who relates the mathematics and the chemistry. The students took the data by themselves, and they did the experiments like a few days, and then collect the data and then model the data using appropriate functions. So in that case, the students' engagement will score as maybe the highest possible. The next one, criterion D, is reflection. It's the criterion D, reflections. Reflections means it's not only reflecting at the end of the explorations. Reflection means the students should comment or describe what is they finds in the middle of the exploration. For example, they present a picture or a figure in the middle of the exploration. Then the students needs to comment what is this picture about? What is the implication of showing this figure to the development of the exploration? Or at certain point, the students gather a certain value. The students need to comment what is this value about, what is the implication of this value to the development of the exploration, and all that comments should be linked to the aim, should be linked uh, to find the answer of the aim that's stated at the beginning of the exploration. They are providing a reflection on the result, and every time that the students get any certain values or a certain result, then they should describe what is this result about and what is the implication of this result to the development of the exploration. At some point, they might compare different approaches or different models that they use, and it should be also commented. It should be also described. If they are comparing between methods or models, they should provide the strength and weakness of each model and the implication for each model to the exploration to the aim, or the implication of each model to answer the aim. And in this case, what else about the? I think that's about the reflection. One more about the reflection. At the end of the exploration, the students should advise what can be done better or what can be improved from this exploration. Or the students can also suggest the ideas for further investigation about this exploration. And the last criterion that we have is a use of math. Again, there is no the only difference between the SL and the HL is in this criterion, the criterion E. In the criterion E, the students, the mathematic use should be commensurate, relevant, demonstrate their knowledge. That is, for example, there is no shortcut of calculation shown in the exploration, especially for Math AA students. They cannot provide the formula and then the result. They should provide the formula and the calculation step by step, and then the result. And then the IB defines demonstrate as to make a clear by reasoning or evidence, illustrating with example or practical exploration. In this case, includes the proof, mathematical proof if they provide some calculations, and the reason why they choose these calculations mathematically. And then the mathematic use is correct. That's why if you are marking the IAs, or if you're in the IAs, please also check the calculation that the students do, because at some point they might misuse of formula or misinput of certain values or miscalculate on some result and etc. So make sure you check this criterion carefully, because this criterion is taking the highest mark. Is like more than almost 1/3 of the total marks. For HL, the addition is sophisticated mathematics should be that what is specifically on the HL rather than SL. The SML has been extended beyond what an SL student should be reasonably expected to produce. Since the way of the weighting of the syllabus between SL and HL are different, and especially the HL is taking the harder math than mathematics should be automatically harder than the SL. Rigor requires at a high level of logical thought in all calculation and justification for claim made. For example, the proof. The student should prove why the concept is chosen in this exploration. And then yeah, precise mathematics. Every calculation must be correct. And yeah, again, you need to check each calculation should be correct, either the formula, either the result or the calculation, inputting values, especially when they show the series of calculations, it might be some mistake made. You need to check that calculation properly. And again, no shortcut should be shown if they are using the certain calculation. However, if they are doing like Pearson correlation test or any kind of statistical test, it's not really necessary to show the step-by-step calculation, since that calculation can be done by calculator or analytical software. I think that's the criterion that we have, 5 criterions that we have. I might show you if you go to the slide. What slide is this? Give me a second. Slide 16, 17.
Hendra, I will share the links in the chat
Yes.
for the attendees. Yeah, the document.
Okay, thank you.
Yeah.
Yeah. If you go to the link, there are 2 links. It's provided, right? It's, wait, give me a second. It's 2 links provided in this PowerPoint in the slides. The first one is the criterion breakdown. Since I am the reviewer of the IA, so I got this from that company. So they break down the criterion into a smaller criteria, and I use this to review the students' IAs. And the other link is the example of the IAs. Anyway, Saheli, can you help me to make a breakout room again?
Yes, so I'll make the breakout room. We have so far 27 or 26,
Yeah,
if we excluding 3 of us.
26.
Yeah.
Maybe we can make 5 because we
Yeah.
have 5 criterions.
Okay.
So each criterion will be discussed within each group. So everyone, in this case, I would like to ask you to mark this example using the criterion given, and each group will get its criterion. Yeah. Group 1 will be criterion A, presentation. Group 2, criterion B, mathematical communication. Group 3, personal engagement. Group D, reflection. And the last one, Group E, use of math.
Okay.
Okay,
Shall I
and
open all the rooms?
okay, wait, one more instruction for Group E. If you still have time, you can mark for both SL and HL. So the criteria, the marking should be different between SL and HL. Okay, I think I will give you about 10 minutes to mark the IA. I'll pop up to your groups. Sahili, can you assign them? You have 10 minutes.
Yes, I have opened all the
And
rooms. They can choose. They will be automatically assigned to the room. I request everyone to accept the breakout room invitation so that you can join breakout room, and then Mr. Hendra will visit you in the breakout rooms. And please
yeah.
have the documents open for your reference that we have shared in chat.
Thank you, Sahili. Yeah, everyone, please join to the breakout room and discuss room 1, criterion A, room 2, criterion B, and etc. Yeah. Thank you. Welcome back, everyone. I hope you had a good discussion within your group. Maybe let's wait for everyone to come back. I guess everyone is back.
Yes, they are
So
all
how is the discussion? Okay, yeah. Thank you, Sahili. Anyone want to share their finding on each criterion? Anyone? Please share how much do you give?
Yes, you can unmute
the
yourself.
students.
There's one, Mr.
Yes,
Mustafa.
please go ahead. Yes,
Okay.
Mustafa.
It was specified for us to give a mark for creativity. So we think that we can give a 1 1 mark for criterion.
Criterion C. Yeah. Personal engagement. Why do you think it's 1 mark?
Nothing was really creative about the idea he did. First of all, the stool, there were no images for the stool from a real life situation or something like this. So we can't guarantee that he was engaged to this IA. He just gives some functions and applied the form with no other creativity. And as well as the reflection in the reflection as well, he didn't reflect with respect to his personal engagement. He just reflected his logical and reliable and so on, but without referring back to his personal aim.
Okay, thank you, Mr. Fatou. So you give us a 1 for the C and also D, isn't it? Anyone else about the other criterion? Anyone? No? Okay, let me just share the marking from the IBO official. It's here. Everyone can see my slides now. So in this case, the criterion E, it's given 3 out of 4. The comment is the exploration is mostly coherent and organized. However, although the use of analytical method does not necessarily mean lack of consciousness. The candidate used a mix of methods without actually using them appropriately to check for shortened calculations. It was not concise. So that's why it's a 3. And then 3 for B with this comment. Anyway, this example you can see on the my IB website. It's provided by the IB. Yeah, for the detailed explanation or the annotated students' work, you can check on the IB website. Yeah. Is there any further or any other questions about the internal assessment or the criterion or etc.? If there is no further questions, I might close my second session in the internal assessment. Thank you, everyone, and I give back to Sahel.
Yeah, thank you. In case you have anything to ask, we will still wait for 2 more minutes because we shared the feedback form link in the chat box. So we want you all to fill it up and submit so that we can issue certificates to you all. So kindly do that and then you leave the session. Meanwhile, if you have anything to ask, either you raise your hand or you can drop your queries to the chat box. Anything is fine with us. We hope that you have gone through inside and understanding. And Hendra, thank you so much for taking this session and the way you have explicitly explain all the criteria with all the nitty-gritty of the criteria. They were just very well organized the way you have organized it. And thank you so much everyone for joining. And please fill the feedback form and then you will leave the session. We'll just wait for 2 more minutes and then I close the session for everyone. Thank you. Thank you for joining everyone and wish you all a very happy weekend.
Thank you everyone. Have a wonderful weekend. Thank you Saheli and Satin. I'll see you in the other workshops, yeah?
Yes.
Bye.
Have
Thank
a restful weekend, Hendra.